For this project of designing a shell and tube heat exchanger, we had to choose a variety of parameters to input into the software Aspen in order to output a desired heat amount of 0.6 megawatts. Some of the specifications to be met were that the tube length could not exceed 25 feet, the exchanger needed to be easy to maintain, and the temperature of the hot fluid could not exceed 120 degrees Fahrenheit.
So for our chosen hot fluid, our chosen parameters were a density of 1.04 and a velocity of 1 meter per second. Two different diameters were used in our design, which gave us two different areas, and therefore those two areas were used to calculate two different mass flow rates.
Our first design had a tube outer diameter of 3 inches, a shell inner diameter of 5 inches, and we calculated the mass flow rate. We used small arbitrary numbers for pressure and had a 50-degree difference between the inlet and outlet temperatures. Those red boxes show what we changed between our first design and our second design.
So like Nicole mentioned for the first design, the second design, the only change that was made was our tube outer diameter, which gave us, in turn, a higher mass flow rate.
The increase in mass flow rate proved to increase the total heat load. Our second design, when we increased the diameter by half an inch, ended up with a heat rate of 0.376 megawatts, which is 0.1 megawatts greater than our first design.
So as seen from our previous results, the 0.6 megawatt goal was not met, and we have come up with possible design changes that could, would say, potentially increase our power output, and which are increasing tube diameter, using a possible different hot fluid, defining different inlet and outlet temperatures, or temperature differences, and changing pressure levels of fluids.
Here's a list of some pump and heat exchanger suppliers that we found online that we thought would do a good job with the parameters we needed to meet.